General facts. 1. Definition. Upthrust, also known as buoyancy, is the upward force exerted by a fluid, liquid or gas, on an object immersed in it. 2. Cause. Upthrust is caused by the difference in pressure between the top and bottom of the object. 3. Direction. Upthrust always acts opposite to the force of gravity. 4. Magnitude. The magnitude of upthrust depends on the density of the fluid and the volume of the object submerged. 5. Archimedes principle. This principle states that the upthrust exerted on an object is equal to the weight of the fluid displaced by the object. Factors affecting upthrust. 6. Density of the fluid. A denser fluid exerts a greater upthrust on an object. 7. Volume of the object submerged. A larger volume of an object submerged results in a greater upthrust. 8. Shape of the object. The shape of an object can affect its upthrust. For example, a boat with a wider hull experiences a greater upthrust than a boat with a narrower hull. 9. Temperature of the fluid. The temperature of a fluid can affect its density, which in turn affects upthrust. 10. Pressure of the fluid. The pressure of a fluid can affect its density, which in turn affects upthrust. Examples of upthrust. 11. Floating objects. Objects that float in a fluid experience an upthrust that is equal to their weight. 12. Submerged objects. Objects that are submerged in a fluid experience an upthrust that is less than their weight. 13. Hot air balloons. Hot air balloons rise because the hot air inside is less dense than the surrounding air, creating an upthrust. 14. Ships. Ships float because their hulls are designed to displace a volume of water equal to their weight. 15. Icebergs. Icebergs float because ice is less dense than water. Applications of upthrust. 16. Naval architecture. The design of ships and submarines relies heavily on understanding upthrust. 17. Aerospace engineering. The design of aircraft and balloons involves calculations of upthrust and lift. 18. Hydraulics and pneumatics. Upthrust plays a role in the operation of hydraulic and pneumatic systems. 19. Marine biology. Upthrust is essential for the survival of aquatic organisms. 20. Geology. Upthrust is involved in the formation of certain geological features, such as mountains and volcanoes. Additional facts. 21. Relative density. The relative density of an object determines whether it will float or sink in a fluid. 22. Center of buoyancy. The center of buoyancy is the point where the upthrust acts on an object. 23. Metastable equilibrium. Some objects, such as a coin floating on water, are in metastable equilibrium, meaning they are stable but can be easily tipped over. 24. Capillary action. Capillary action is a related phenomenon where a liquid rises in a narrow tube due to surface tension and adhesion forces. 25. Bernoulli's principle. Bernoulli's principle is a related principle that explains the lift force on objects such as airplane wings. Continue with facts 26 to 50. Facts 26 to 50. 26. Negative upthrust. In some cases, the upthrust on an object can be negative, meaning it pulls the object downwards. This happens when the object's density is greater than the fluid's density. 27. Hydrostatic paradox. The hydrostatic paradox states that the pressure at any point in a fluid is equal in all directions, regardless of the shape of the container. 28. Pascal's principle. Pascal's principle states that pressure applied to a confined fluid is transmitted undiminished to every point within the fluid and to the walls of its container. 29. Hydraulic press. The hydraulic press is a machine that uses Pascal's principle to amplify force. 30. Buoyancy compensator. Divers use buoyancy compensators to adjust their buoyancy in the water. 31. Hot air balloon racing. Hot air balloon racing is a sport that relies on understanding upthrust to control the altitude of the balloons. 32. Submarine ballast tanks. Submarines use ballast tanks to control their buoyancy and dive or surface. 33. Hydrostatic weighing. Hydrostatic weighing is a method used to measure body composition. 34. Hydrometers. Hydrometers are instruments used to measure the density of liquids. 35. Pycnometers. Pycnometers are another type of instrument used to measure the density of liquids. 36. Drag force. The drag force is the force that opposes the motion of an object through a fluid. 37. Reynolds number. The Reynolds number is a dimensionless quantity that helps to predict whether flow will be laminar or turbulent. 38. Laminar flow. Laminar flow is a type of fluid flow where the fluid moves in smooth layers. 39. Turbulent flow. Turbulent flow is a type of fluid flow where the fluid moves in a chaotic manner. 40. Fluid dynamics. Fluid dynamics is the study of the motion of fluids. 41. Viscosity. Viscosity is a measure of a fluid's resistance to flow. 42. Surface tension. Surface tension is the force that acts at the surface of a liquid, causing it to behave as if it were covered by a thin skin. 43. Cohesion. Cohesion is the attractive force between molecules of the same substance. 44. Adhesion. Adhesion is the attractive force between molecules of different substances. 45. Capillary action. Capillary action is the ability of a liquid to rise in a narrow tube due to surface tension and adhesion forces. 46. Meniscus. The meniscus is the curved surface of a liquid in a container. 47. Contact angle. The contact angle is the angle between a liquid and a solid surface. 48. Wetting. Wetting is the ability of a liquid to spread over a solid surface. 49. Non-wetting. Non-wetting is the inability of a liquid to spread over a solid surface. 50. Hydrostatic pressure. Hydrostatic pressure is the pressure exerted by a fluid at rest. Facts 51 to 75. 51. Hydrostatic paradox. The hydrostatic paradox states that the pressure at any point in a fluid is equal in all directions, regardless of the shape of the container. 52. Pascal's principle. Pascal's principle. Facts 76 to 100. 76. Bernoulli's principle. Bernoulli's principle states that as the speed of a fluid increases, its pressure decreases. 77. Venturi effect. The Venturi effect is an application of Bernoulli's principle where a narrowing of a pipe causes an increase in fluid speed and a decrease in pressure. 78. Lift force. The lift force is the upward force on an object moving through a fluid, such as an airplane wing. 79. Drag force. The drag force is the force that opposes the motion of an object through a fluid. 80. Terminal velocity. Terminal velocity is the maximum speed that a falling object can reach due to the balance between the force of gravity and the drag force. 81. Stokes' law. Stokes' law describes the drag force on a small, spherical object moving slowly through a viscous fluid. 82. Fluidization. Fluidization is a process where a solid material is suspended in a fluid, making it behave like a fluid. 83. Sedimentation. Sedimentation is the process where particles in a fluid settle to the bottom due to their weight. 84. Filtration. Filtration is the process of separating solids from liquids or gases using a porous material. 85. Centrifugation. Centrifugation is a process used to separate components of a mixture based on their density by spinning it at high speeds. 86. Chromatography. Chromatography is a technique used to separate components of a mixture based on their affinity for a stationary phase. 87. Distillation. Distillation is a process used to separate components of a mixture based on their boiling points. 88. Evaporation. Evaporation is the process where a liquid changes state to a gas. 89. Condensation. Condensation is the process where a gas changes state to a liquid. 90. Sublimation. Sublimation is the process where a solid changes state to a gas without passing through the liquid state. 91. Deposition. Deposition is the process where a gas changes state to a solid without passing through the liquid state. 92. Phase diagram. A phase diagram shows the conditions under which a substance exists in different phases: solid, liquid, gas. 93. Critical point. The critical point is the temperature and pressure at which a substance can exist as both a liquid and a gas at the same time. 94. Triple point. The triple point is the temperature and pressure at which a substance can exist as a solid, liquid, and gas at the same time. 95. Boyle's law. Boyle's law states that the pressure of a gas is inversely proportional to its volume at constant temperature. 96. Charles's law. Charles's law states that the volume of a gas is directly proportional to its temperature at constant pressure. 97. Gay-Lussac's law. Gay-Lussac's law states that the pressure of a gas is directly proportional to its temperature at constant volume. 98. Ideal gas law. The ideal gas law combines Boyle's law, Charles's law, and Gay-Lussac's law into a single equation. 99. Real gases. Real gases deviate from the ideal gas law at high pressures and low temperatures. 100. Van der Waals equation. The van der Waals equation is a more accurate model of real gases than the ideal gas law.